Welcome everyone, and thank you for joining us for the January Weiler Wednesday webinar on measuring grinding wheel performance. My name is Tony Hufford, and I'm the category manager at Weiler Abrasives. Today, I'm joined by Elliot Shepard, our associate product manager, and Michael Zuloff, our product design engineer. Our industry experts are going to discuss evaluation of grinding wheel performance. Before we jump into the webinar, just a quick updates on our response to COVID-19. Weiler Abrasive continues to navigate this ever-changing business environment caused by the pandemic. Our priority remains maintaining the health and safety of our customers, coworkers, and communities while continuing to service our customers. We continue to operate all of our manufacturing facilities and distribution facilities around the globe. We are in close contact and support with our suppliers to continue to mitigate any type of supply chain risks that develop. And our sales team is here to support you in the safest, most efficient way possible, whether that be in person or virtually as we're doing today. And we continue to operate our work remote policy with our customer service and some of our inside sales team. Just want to share a few tips on the Zoom webinar platform. We've muted all lines to prevent background noise. If you have any questions, feel free to use the Q&A function, and we'll answer those questions at the end of this call. You will see a poll question appear towards the end of the presentation, and we appreciate your feedback on this. And finally, if you're using the Zoom app, we recommend switching your view to gallery so you can see all of our speakers on the screen at one time. On the desktop, you can do this by clicking the view icon in the upper right corner. On a smartphone, you can switch views by swiping left. So let's get into the webinar, our agenda. You're going to learn how to accurately measure grinding wheel performance, learn some best practices from our experts, and really talk about the value of automated testing, offhand testing, and we're going to walk through the results. So from an importance of proper evaluation of grinding wheels, the first question you might ask yourself is, why even bother to test? And testing has been proven to save time and money. You may have always used the same grinding wheel. You may have never had a problem with that grinding wheel. That doesn't mean it's the best grinding wheel for your application, and it doesn't mean you can't get better results with some newer technologies. So it's important to realize that not all grinding wheels are created equal. And that brings us into the opportunity to make sure you have that right wheel for your specific application. And as technology continues to evolve, it is always a good idea to test new products to see if you can be more efficient. Product testing also allows you to choose based more than just price. And not understanding how product performance affects your application often winds up costing you more in hidden costs than the initial price may suggest. So just looking at the different tiers that are offered, operator efficiency and ergonomics, and changes over time can be reduced in high labor environments. Some critical factors, or what people look for most when they're doing their testing, is they want to know how long the grinding wheel lasts, so the grinding wheel life. And you can see to the picture in the right, some of the wear patterns are being evaluated after a test has been conducted at a facility, and really just visually looking at how long wheels last. And our experts are really going to get into how you evaluate that from a data standpoint. The second thing people look for is how much work's being done, how much material is being removed, and how fast is that being done. So as you look at that photo to the right, you can see the beveled edge, and that's the work that's being done, and the material being removed is evaluated, and from a time standpoint, really looked at and put together in a G ratio. G ratio may be a term that a lot of you aren't familiar with. Technically speaking, it's the amount of material removed divided by the disc loss. It creates a number that's a general guide that helps us differentiate product, but it's certainly not the final decision point. You need to focus on your application needs. For example, is speed more important than life? G ratio may not be the best indicator of that. When I think about G ratio, and I talked to my friend Rick about this, think about buying a Ford 350 and a Toyota Prius. Both are capable to reach 80 miles an hour, and both are capable to get you to the same place on time. But one's going to use much more gas than the other. One of those things may be more efficient or be more important to you. So you just have to think about it holistically for your application needs. And we're going to talk through some automated and offhand testing today. And we talk about feel and real performance with this. And from an offhand testing standpoint, really love it because you can mimic applications. You really get a feel for the wheel, how it runs. Does it require any type of testing equipment? But one of the cons is that people tire over time. I know I tire over time after I've been testing all day, and results do vary between operators as they would in real life. From an automated testing standpoint, you get same pressure, same angles, RPMs. Machines don't tire, so you really get consistent results with this similar feel. They do require special testing equipment, and often it doesn't mimic real life application, and you certainly don't get any feel for the wheels. So that's why we really combine both to get the clearest picture, and our experts are going to walk through and talk about both of these operations and really how to read the data and put the data together. But first, we always want you to think SPOT. And SPOT stands for speed, size, pressure, orientation, and time. Throughout this discussion, you'll see references to SPOT. You'll see our experts being safe always. And we're proud to provide this comprehensive OSHA compliant safety program called SPOT that really reviews proper PPE, abrasive, and wire products, as well as safe operation of right angle grinders and die grinders. So if you spot someone being safe, recognize them. And we say if you spot someone being unsafe, really help them out. So from that standpoint, Elliot, why don't you show us really how to set up and get consistent results with our data?
Sure thing, Tony. I appreciate it. So as Tony said, my name is Elliot Shepard. I'm an associate product manager for Weiler Abrasives. And before this job, I was actually a fabricator for a number of years. So I've been on both sides of this abrasive use. So I've been that fabricator. I've done the testing for the abrasive companies, and now I'm on the opposite side as that product manager and really trying to educate people to do the right thing. So just to kind of start out with, I just want to start off with safety, always number one, most important. So we have our gloves, steel toes, apron, and some things that people miss is, you have your safety glasses, but you always want to use a face shield. And then always use your ear protection because you want to be as safe as possible. All it takes is one hiccup and you could go home having a bad day. So just to point that out. So when I go to a facility and do any testing, I really look for what is happening in the facility, what can we test, and really what can we get our operators to work with. We're going to be looking for some sort of test where we can do up to 25 minutes per disc. I like to do a range of between 3 and 5 minutes at a time, but we want to make sure we keep it consistent. So if I choose 3 minutes, then I'm going to go 3-minute intervals. And then every 3 minutes, I'm going to weigh and measure both disc and the workpiece, and I'm able to get that data. And then by the time I'm done, I can compare the two. You'll hear me talk about this a lot, but the biggest thing for testing is consistency. So we want to make sure we're using the same person. We want to make sure we're using the same material, and as best as possible, using an application that is being done at that production facility. So I'm going to walk through some of the things that we can that can become inconsistent during the test. So just really starting out first with our clamping situation. So you can use a number of different clamping situations. So our weld clamps, C-clamps, our table vices, or something as simple as a jaw horse, which we use a lot for our testing internal. And then for a lot of our training facilities, we'll use a jaw horse as well. So the big thing about these clamping mechanisms is making sure that we have optimal clamping. And when I talk about optimal clamping, I want to make sure that the amount of material that's outside of this vise is minimal. So as you can see, generally we won't grind on such thin gauge material, but for viewing purposes, you can see how much flex is in this piece of material. So you can imagine if I were to put a grinder on this, it's going to chatter, it's going to go all over the place. And that's going to minimize the life of the abrasive. So we want to be able to actually clamp in and have minimal vibration or cancel it out completely to be able to use that disc as its purpose was intended. So that kind of applies with our table vices, our C-clamp, and our welding clamps as well. So looking at power, we want to be able to use something along the lines of a more industrial extension cord when we're using extension cords. Length is important, and then that size of the extension cord. So this isn't going to be something that we're going to be using for our Christmas lights. We're not going to be using something that's thin. We want to be able to get that power from the receptacle to the tool as efficiently as possible. So using a larger gauge wire, 12, 10 gauge, is a lot better than your typical Christmas light, which is about the 14 or 16. That'll allow your tool to run efficiently and more predictably. So as we move into more of the tool-based factors, we want to make sure that we're using the correct tool for the job. And I've seen this a number of times using the wrong diameter on the wrong tool. And with the size of 6-inch grinders and 4.5-inch grinders getting closer and closer, it's getting a little bit harder to tell. So we're making sure that we're using the right size product on the right grinder. So whether it's a 7 and 9-inch size grinder, a 4.5-inch grinder, or a 5 and 6-inch grinder, we want to make sure that we have the right piece available. The next thing we want to make sure is that our guard on the grinder is between you and the workpiece and the abrasive at all times. It can move and adjust to whatever application you're going to be doing, but we want to make sure that it is always in between you and the grinder, as sparks will fly. We want to be able to minimize any possibility for risk. So one big thing I'd like to talk about too is the timing of when we actually go and do tests. We really don't like to do any type of test in the afternoon. As a fabricator, I'm done grinding 3 or 4 o'clock. I don't have the energy to keep going. So if somebody comes in at 3 o'clock and wants me to test 2 discs, I know that's going to be an hour. I'm not going to put my whole effort into it because I'm tired, right? So I'm going to push my tests into earlier morning, 8, 7, something where they first get in, they're ready to go, and they have you know, that good night's sleep to be able to give a fair trial between 2 different wheels. And then after that is going to be looking at attack angles, pressure, and understanding what that operator is doing with that test. So as I set this up, Tony, you want to pull through as I set this piece up, and we'll talk about attack angles?
Yeah, that's a good point, Elliot. But I just want to go back to something you mentioned with the guards and how easy they are to maneuver. A lot of times we're at facilities, people say the guard gets in the way, you know, they just can't use it. And they're really easy to maneuver, really easy to manipulate nowadays. So as you keep the guard on, you can position it in a place where it was comfortable for you and for your application. And you notice there, Elliot just plugged in that grinder. So everything he's been doing as he uses the grinder or puts the product on the grinder, he's got it unplugged before he does that. And Elliot's going to walk us through really some angles of attack that he's going to demonstrate. And we'll walk through that right now.
Right, so with angle of attack, when you have a larger angle of attack, you're going to be a lot more aggressive. So with the disc not moving, larger angle of attack going across the piece, you're going to have more material removal, able to put more pressure down on it. As a lower angle of attack, you'll have less material removal. You'll be able to control the disc a little bit better. But the thing is keeping this consistent as you're working through. When you see somebody that has a high angle of attack, you'll also probably hear that grinder bog down because of the pressure they're able to put on it. So keeping notice of how much pressure is being put on when you're doing 2 different tests and you're watching that operator do 2 different tests, you'll be able to see if that's really a fair test. Understand where they're pressing a little bit harder maybe on the first piece and not so much on the second piece. But we'll just keep that in mind as we go through. So what I'll do now is I'm going to demonstrate some of the high angle attack, a low angle attack, and then we'll see how we do with this here. And Tony will walk through as I put these earphones on here and start up.
Thanks, Elliot. So as Elliot really prepares to grind, and as you watch him begin his grind, he's going to start with a pullback motion. And we talk about a pullback motion a lot because that really sets the tone, gives you an even face as you do that. So as he pulls back and runs that grinder, you can see also he's using his body. He's not pushing out with his arms. He's able to control that piece as he works through there. And with that higher angle, he's going to get a lot more material removal. It's going to be very aggressive, but that disc is going to wear down quicker. And with a lower angle of attack, which may be necessary depending on the application and the space that you see, he's going to get less material removal in general, but he's also going to have a disc that lasts a little bit longer, and it's going to wear a little differently as well. And Mike Zuloff, better known as Z to his friends, is really going to walk us through how to measure that, how to see that, and work through that. So Elliot, thank you very much for all of that hard work. And Z, we're going to move it over to you really to talk about automated grinding and how do we use all this data that we're collecting.
Okay, thanks, Tony. Thanks, Elliot. My name is Mike Zuloff. I'm a product research and development engineer here at Weiler Abrasives. So I get to design the products. I get to design the machines and the tests, the automated tests, and I also get to perform the offhand tests with the team. So that way I understand how the product works in your hands. So I'm going to start off, I'm going to show you our automated machine, and then I'm going to talk about how a grinding wheel wears away and how to use the data that you get when you do your test. So here's our machine. This is the one we use for the 4.5-inch grinding wheels and above. You've got your workpiece, just like an offhand. We can set the speed of this to spin, so that way it wears away evenly. And then we have an inverted cradle with holding a grinder. Okay, here's our wheel. So we can adjust the angle, we can adjust the height, and we can adjust the pressure so that it can apply pressure and cut away at the workpiece. So that's our machine. It allows us to get a lot of data fast and to do a lot more samples than you can do, being one person. So now I'm going to talk to you about how a grinding wheel wears away. Okay, so this is a representation of the usable life of a grinding wheel. It's set up into 4 colors, which each of those colors is 25% of the life. So when you start out, you're grinding on edge. You have good control, but what we want you to see here is that it takes more than 25% of the life before you even fully wear in your wheel. And this is showing a 30-degree angle, which is pretty much middle of the road. So when you start off, good control, good cutting. You're going to slowly create your 30-degree contact patch on your wheel. Now you're into the next phase, or the next 25% of your wheel life. It's gonna feel similar to when you started. Good consistent cutting. As your wheel wears away, you're going to start to get closer and closer to smaller diameter, and it's hard. It's going to be hard to tell how fast, but you're going to start to get a feel that you're losing grinding wheel material. And then finally, towards the end, you've got a smaller diameter. That's when you're going to feel most of the removal of the wheel itself.
This is a good representation of that flatter angle grinding that Elliot was just showing us.
Right. So just to talk about that diagram, what you want to do is once you get your angle, if you increase your angle further, you're going to lose the wheel a lot faster because now you're cutting on a much thinner area. So I just wanted to point that out. So here we are. Here is a fully filled out table for our data. Obviously, when you start out, there's no data in there. And we set up an Excel spreadsheet to automatically calculate the disc loss and the workpiece loss, or the test piece loss. So it would be blank at the beginning. You would test your new grinding wheel, or you would weigh your new grinding wheel, and you would weigh your workpiece, record that, and then you run your first 5-minute cycle. When you're done, you pull your wheel off, weigh that, take your workpiece, weigh that again, and now you're starting to see that you're losing material. Okay, and you're going to continue that throughout. If you can, you want to do the whole life of the product. That's what we recommend. Obviously, the bigger the product, the more life it's going to have, and it might not be practical at that point. But a 4.5-inch grinding wheel is about 30 minutes of life, give or take, depending on the model. So, so once you get to the end, you're going to get a feel for, there's going to seem like there's a winner, but you also want to see what happened throughout the entire life of the product. So that's why we're going to graph the data and see how each different product behaved. So on the left, we've got pictures of our used up discs. You can see sample A on the top. It made it 30 minutes. It's got middle of the pack performance. It's pretty much used up. Now, the middle one, sample B, that one has a little bit more life left. We could have actually kept on testing that, but we stopped. You know, we had a good feel for what we were getting. And then C was obviously had the shortest life and the worst G ratio. You know, it just wore away quicker than the others. Okay, now, so now we want to, you can see our little diagrams on the right there. That's showing where each disc is in its lifespan. We're within the first 10 minutes. You can see that there's similar cut rates at this point. The blue and the gray, sample B and sample C kind of were out to a little bit of a lead, but then everything converged. And at that point, all three samples continued to cut at essentially the same rate, okay? But what you're gonna notice is which one is wearing away the fastest. So you can see that obviously C is wearing away the most. A and B at this point are neck and neck. You know, it's hard to tell who's better, you know?
Yeah,
so
Z, I think it's been really important to note, right? A and B have switched places almost on how they look or how they grind. So as this test progresses, you may not make the best decision after the first 5 minutes that you would after the 30-minute test. So it's really important for efficiency's sake.
Right. You don't want to cheat yourself. You want to get as much information as you can when you test. So this is showing the full 30 minutes. At 25 minutes, C was used up. Okay. And again, they're all cutting pretty much the same. At 30 minutes, there's about a 10% difference in what's been removed between samples A and B. Okay. But you also notice, okay, A is just about used up also. So that's where we stopped. You might be able to get it another minute or two, but B still has life left. So, you know, you may want to keep testing that until it's all used up. So we ended up doing one more 5-minute cycle. It was still had life, sample B, and it was still cutting consistently. So at that point, you've overtaken the other samples and you still have life left. So, you know, that gives you the impression B is in the lead, but depending on your cost structure and your application, you know, maybe it isn't. But now you have a good picture so you can decide and choose the wheel that is best for you.
Yeah, thanks, Z. It's really important as we went through that graph. A lot of things changed. My opinion changed of the products, and certainly the life of the products really stood out as you worked through that. So really important that you take all this from an automated standpoint, tie it into what Elliott was giving us from a feel, really perspective of that, and we really understand what product's right for us. So thank you, gentlemen, for that. And as a wrap up, it's safety first. We're choosing the right wheel for our application. We're always keeping the guards on. We're not over tightening them. And we're just making sure we wear our PPE. To maximize performance, we're checking our power, not pushing too hard, everything that Elliott really described and went through. And you'll see a poll that just popped up. So we really want to know from a testing standpoint, have you requested, participated, or completed an abrasive performance evaluation? And then are you interested really in performing these evaluations? And Weiler can definitely help you out with that. Obviously, we have the expertise in not only performing the test, but really understanding and working through the data. From a resource and next step, this Weiler consumable productivity program, you can see it to the right. It's really a case where we're including information. You're able to really calculate this, show efficiency, show what product's right for your application. We've got case studies that can show what lasts longer or what may work for specific industries, as you can see with a pressure vessel case study. And then really just to work through our field testing, you can work with the DSMs or call our customer service. So contact us today and we can help you out increasing your productivity. From an upcoming webinar, Elliott should be familiar to you all. Team did a great job today. Elliott's going to be working with Rick Hopkins next. I know both of these gentlemen personally. They know abrasives, and they're going to be talking all about resin fiber disc program, live demo, and really just how to use these products. So don't miss that next month, February 24th. And then we thank you all for your time. So we appreciate that, and we're going to open it up for questions.
Thank you, Tony and team. We do have quite a few questions here that I will read off and allow each of you to answer as your expertise provides. So we'll start off with question number 1. How do I get in contact with Weiler to have a safety training scheduled?
So I can help out with that one, and Tony, you can add into. So we have our district sales managers that would generally do the trainings. They can be done virtually as well, but also on our website, you can get in contact with us through WeilerAbrasives.com and fill out a sheet, be able to send it over to us, and we can contact you and schedule for either virtual or with the COVID times, we can be in your facility too. So depending on how you'd like to do it, that's the best way.
Yeah, thanks, Elliot. Yeah, if you can't wait or you want a test right now, you can contact us today. I've put some information online that you can see here from a phone number, or really go through the website or contact your local DSM.
Next question, how many discs should I test to truly get an accurate understanding of the G ratio results?
I'll take this one. You know, it's always the more the better. If you're doing it offhand, you can get away with one of each, but you know, ideally you do 2, do 3, at least 1, obviously. But I would do 2 or 3 if you have the opportunity.
I'll just add something to that too. So with abrasives, you'll notice sometimes with certain manufacturers that one wheel will be cutting like hell and doing great, and then once you get to the middle of that box, it kind of goes down and it doesn't cut the same as the that first one you pulled out. So especially when we do offhand testing with new products against some of the competitors, we try to do 3 to 5. But again, that's a lot of time. It's a lot of work. And a lot of times when we're in a facility, it's tough too. So I like to stick to 2 as a really, that point. So at least 2. So that's what I would say, just to add to Mike's point there.
Thank you, team. Next question, how do I gauge how much pressure is too much pressure when grinding?
So when you're grinding, you should be able to hear that motor bog down if you're having too much pressure. Your grinders are made to spin at an operating RPM, and you want to really try and keep it at that RPM because the abrasive is made to spin that fast. So once you start adding more pressure, you'll hear that motor drop and those RPMs drop. That's how you know you're adding too much pressure. Another way to look at it visually too is if you start to get heat discoloration. That'll generally mean that you're adding too much pressure into there, which is generating too much heat, which is the ultimate enemy of any abrasive, is overheating. So that's going to cause your grains not to be as efficient as they should be.
You also may see burning when you're grinding.
Right.
Thank you, team. Next question, is automated testing available at Weiler for anyone?
I mean, yeah, if you contact us and, tell us what you're using, we'll dig in and see, where that product falls, and we'll test a range of our products against it and give you the data, the results.
Next question, what is the recommended time for testing a product to get a good feel for its performance?
So I'll take that one if that's all right. I would honestly, I try to run them to life. Obviously when you're in a production environment, time is money. So generally and it depends on the product itself. Grinding discs are going to last longer than flap discs, as they're going to last longer than surface conditioning discs. So depending on the product really is going to be the key there. But as Mike said, I really like to stay in that 20 to 30 minute per disc, or at least get it as close to life as possible. That way you're going to be able to tell the consistency of that disc compared to the next one you're testing against. And the reason why we asked you to go as much as possible as far into the life of the disc is that the density of the outer part of that wheel could be perfect and hard and right where you want it to be as far as the product. But as you start to dig into that disc and get closer to the inner diameter, you can see a little bit of a less dense product, and it could burn through a lot quicker. So understanding that, you know, maybe the first 3/4 of that disc is running perfectly, and then it just burns up at the last inch that is usable around that bonded abrasive. That's really the key for consistency, is to try and get as close to the life of the disc as possible. But whatever it is, make sure you do it with both. Don't hit one with 15 minutes and another with 30. You're not going to get the right data.
Yeah, Elliot, and as we walk through what the data that Z showed us, I personally and the team, right, we stop every 3 to 5 minutes to really look at the disc, look at those different wear patterns that we're seeing, and just see how it visually changes over time. So it's not that we're running these 30 minutes straight. We're typically stopping every 5 minutes. For me, really, because my arms can't go any longer, but really to give us some consistent data, and so we're able to evaluate it throughout the life of the disc, except for just the stop and start.
Right, and I just want to add one thing. The data I was explaining to touch on what Elliot had said about consistency. Sample A and sample B were the better performers, but at a certain point, I think it was around 25 minutes, sample A started to accelerate its disappearing act. It started to really lose grinding wheel material at a faster rate than B, which is why B still had life left. So that indicates that sample A is less dense as you get towards the center.
Thank you, team. Next question. Is there a record of all the wheels that Weiler has tested so that we can compare competitors' results to Weiler without having to do the testing ourselves?
I might have
take,
to add, yeah, I was going to ask Tony
go
to hit
ahead.
that one for me.
I'll take that one. So we do keep a database, but it's certainly specific for Weiler. It's not something that we share or is public knowledge, but we utilize it to make the best decisions, to work with our partners, really to recommend the appropriate products.
Thank you. Follow-up question. Did you say, this question is for Michael, did you say that the test pieces that you are grinding on is spinning?
Yes, it's turning. You know, if it was stationary, then the grinding wheel would just start digging in, and then you would waste most of it. You would just dig in here, but we spin it so that way it evenly wears away the disc. The larger when it's a new piece, we turn it slower than when it gets smaller, because when it's new, it has larger OD, obviously, which means it has more surface speed. As it gets ground away, in one turn, the grinding wheel sees less surface to cut. So that's why we speed it up, to keep a consistent surface speed of this point, of the grind point, against the grinder.
Thank you. We have just a couple more questions here. When I grind aluminum, it doesn't seem to matter how I use the grinding wheel. It stops grinding. What am I doing wrong?
So I'll take this one. It's a little bit close to my heart. So with aluminum specifically, you really want to look at an aluminum specific product. A lot of the products that are out in the market that are not aluminum specific won't have a grinding aid additive to the bond or to the abrasive itself. So with aluminum, it gums up really easily. So it'll fill those grain spaces and basically burnish and smooth out. So you're no longer grinding with the abrasive. You're really just smearing aluminum around. So when you use an aluminum specific product, like some of the Weiler aluminum grinding wheels or our Weiler specific aluminum flap disc, the Tiger aluminum, those have grinding aids in there specifically to be able to allow that the material that you're removing to actually let go of the abrasive on the product and keep it clear to keep cutting. So I would look into some of the Weiler specific aluminum, Tiger aluminum products and grinding wheels. We have RFDs and flap discs. And I'm pretty proud of the Tiger aluminum flap disc that just came out. It's a dual flap design, specifically made for aluminum, and it does quite well. So have a look on our website. You'll be able to possibly pull a sample there and try it out for yourself.
Thank you. Next question. How much of a grinding wheel can I actually use? I use them all the way down to the hub.
Yeah, I'll take that one. I mean, we showed you the diagram. In this case, it was a depressed center wheel. So basically we use it until you hit the depressed part, just looking at the gray area, you could probably get a little more life out of it. But that's where, at a 30-degree angle, that's where you start to hit your, the fillet or the rounded part of the bottom of the disc. So that's where we tend to stop. But I mean, if you can get more life out of it, it just might not be as consistent at that point.
Yeah, one of the things I find all the time when I'm using a grinding wheel is it gets down really small, it starts to walk on me. So it's not necessarily that, so it's not grinding as fast, certainly, but starting to walk, I'm losing a little bit of control. I find myself having to focus more on controlling really the angle and really the dispersion of the grinding disc in that standpoint. So not only does it grind slower, but you'll feel it start to, I call it walking, but you'll feel it start to be hard to control. And that's really when you know it's time to change that disc.
Thank you, team. Our final question is, will we receive a copy of this webinar?
Yeah, all the webinars are recorded and available. So they'll be made available, I think, through our website, Heather.
Thank you, Tony. That's all for the questions.
All right. Well, thank you, everyone. We appreciate your time. I'd like to thank our experts, Z and Elliot as well. Everyone, I learned a lot, so hopefully you did too.